and gentlemen, lovely viewers, my name is Daniel and I want to welcome you officially to Study with Delta. This is a channel where we study math and science every week. So I want you to stay tuned and get ready to learn, because every week I'll be coming your way with videos. We'll also be looking at preparations for WASSCE and BEC. So if you're a WASSCE candidate or a BEC candidate, stay tuned and expect more from this channel, because we'll be covering some of the questions that you will be facing and some tips that can help you during your WASSCE time or your BEC time. Today we have an exciting video on atoms and elements. So let's quickly look at the learning objectives for the day. We want to look at what is an atom and element. Then we'll look at examples of elements, common examples of elements that we all know. We'll look at the first 20 elements. Then we'll end the lesson with the periodic table. Now, let's look at the first objective. What is an atom and what is an element? Now, the universe we live in, or the world we live in, everything around us is an example of matter. You know, some time back we learned about matter, anything that has weight and can occupy space. And we saw that matter can exist in 3 different states: solid, liquid, and gas. Now, I said earlier that everything around us is an example of matter. So, for example, salt is an example of matter. Water is an example of matter. Blood is an example of matter. Carbon dioxide, oxygen. Now, all these substances that I just mentioned, they are made up of certain substances called elements. Everything around us is made up of elements. They form the basics, they form the foundation upon which those substances are built. Before you build a house, you need a foundation. So everything around us fundamentally is made up of elements. Remember I mentioned water. Water is made up of hydrogen and oxygen. Salt, which is a common salt, is made up of sodium and chlorine combined together to give you sodium chloride. So it's made up of the elements sodium and chlorine. Carbon dioxide. Human beings and animals breathe out carbon dioxide. Carbon dioxide is made up of carbon and oxygen. So you do realize that everything around us contains elements. Human beings have elements in us. If you want to break human beings down to their very smallest unit, you realize that we are fundamentally made up of elements. Now that we have understood that everything around us contains elements, then let's look at what then is an atom. An atom. Now, let's do a little recall. In biology, we learned about cells. We learned that cells are the basic unit of life. Every living thing started out as a cell. So we learned the organization that you have a cell that comes together to give you a tissue. Then the tissue comes together to give you an organ. Then the organ comes together to give you an organ system, like the reproductive system, the circulatory system, the nervous system. Then these systems, in conjunction with other systems, come together to give you an organism like a human being. So human beings started off as cells. So the basic unit of every living thing is a cell, because we started out as cells. Then we progressed, we developed to become an organism. Now, what a cell is to an organism, that is what atoms are to elements. So what do you think atoms will be? Guess? An atom is the smallest particle of an element. Remember we said that cells come together to form an organism. That is what happens with elements. Elements basically are made up of tiny particles. Very tiny particles that the naked eyes cannot see them. So every element is made up of atoms. So you have atoms that come together to give you an element. Then the element comes together for it to give you matter. Interesting, right? So let's look at the definition of an element. What is an element? An element is a substance that is made up of the same kind of atoms. An element is a substance that is made up of the same kind of atoms. Now the key word over here is same kind of atoms. You can have something like carbon dioxide. Carbon dioxide contains carbon and oxygen. So we can't call carbon dioxide an element. But when we take gold, gold contains only gold atoms. Oxygen contains only oxygen atoms. Hydrogen contains only hydrogen atoms. When you take salt, sodium chloride contains sodium and chlorine. So you do realize that the key word I used over here is very critical. An element is a substance that contains or that is made up of the same atoms. We'll look at elements, examples of elements in a bit. But then let's look at the definition for an atom. Atom is the smallest particle of an element. The smallest particle of an element. Don't forget that atoms cannot be seen with the naked eyes. Now, having laid this foundation down, let's look at examples of elements, common examples of elements. We have gold, we have oxygen, we have platinum, we have aluminium, we have calcium in our body, we have zinc, we have manganese, we have lead. These are all examples of atoms. But today we are going to fixate our lesson on the first 20 elements. So we know what atoms and elements is. We know what is an atom and an element. We also know examples of elements. Now let's look at the first 20 elements. Now, having used the word first 20 elements, it means that we don't just have 20 elements. There are actually 118 elements that are in the world or in the universe. 118 elements. Out of them, 94 are naturally occurring and 24 are man-made. So 94 naturally occurring elements, then 24 are man-made. So for the purpose of JHS and Cambridge, Lower Cambridge, we'll look at the first 20 elements. So on the screen you can see the first 20 elements. We are going to go through the first 20 elements, their atomic number, in which in the future lessons we'll look at what the atomic number stands for. So we'll look at the elements, their symbol, and their atomic number. Now the first element is hydrogen with atomic number 1. Helium with atomic number 2. You realize that the symbol for hydrogen is H, atomic number 1, hydrogen. Then helium, atomic number 2, He. Lithium, atomic number 3, Li. Beryllium, atomic number 4, Be. Boron, atomic number 5, B. Carbon, atomic number 6, C. Nitrogen, atomic number 7, N. Oxygen, atomic number 8, O. Fluorine, atomic number 9, F. Neon, atomic number 10, Ne. Sodium, atomic number 11, Na. Magnesium, atomic number 12, Mg. Aluminium, atomic number 13, Al. Silicon, atomic number 14, Si. Phosphorus, atomic number 15, P. Sulfur, atomic number 16, S. Chlorine, atomic number 17, Cl. Argon, atomic number 18, Ar. Potassium, atomic number 19, symbol K. Then the last element in the first 20 elements, calcium with atomic number 20 and the symbol Ca. I know you would think this is a lot to grasp into your memory, but actually there's a simple mnemonic. A mnemonic is something that helps us to remember something. So there's a simple mnemonic that can help us to remember the first 20 elements. So I've listed the mnemonic for us over here. Now, this is how it goes. Hello, hello. Lesson BBC, now on foreign news. No more allegation, so please send Claudia away. King Charles. Let's take it one more time. Hello, hello. Listen, BBC, now on foreign news. No more allegation, so please send Claudia away. King Charles. Cool, right? One more time. Hello, hello. Listen, BBC, now on foreign news. No more allegations, so please send Claudia away. King Charles. Now these mnemonics, so hello stands for hydrogen, the second hello, helium. Just remember that hydrogen is the first element. Then lithium is listen, B for beryllium, next B for boron, C for carbon, then now for nitrogen, on for oxygen, foreign for fluorine, news for neon, no for sodium, more for magnesium, allegation for aluminium, so for silicon, please for phosphorus, send for sulfur, Claudia for chlorine, away for argon, king for potassium, then Charles for calcium. Now note this, that sodium, then potassium. You do realize that sodium is supposed to, you would think sodium should begin with an S, but the mnemonic and the symbol is N. This is because some of these elements we have, they were derived from Latin words. So the Latin word from which sodium was derived from was natrium. So Na. Then potassium was from kalium. The Latin word kalium, so K. But I think with this mnemonic in mind, you can easily remember the first 20 elements. Hello, hello, listen, BBC, now on foreign news. No more allegations, so please send Claudia away. King Charles. Interesting, right? One more thing on this. Now, silicon and sulfur. Sometimes you will bring silicon for sulfur. Just remember that silicon has an I. And in alphabet, I comes before U. This is atomic number 14. This is atomic number 16. So all the time, silicon should come before sulfur so that it will not confuse you. So silicon should come before sulfur. Interesting. So now we've dealt with the first 20 elements. Now let's look at the periodic table in a bit. Now the image you have in front of you contains the 118 elements. But for the purpose of this lesson, we are going to condense it a little bit, tailored, suited for the first 20 elements. Now, it is critical for us to understand that the periodic table can be grouped into two categories. So all the elements in the horizontal, when you are looking at it horizontally, can be called periods. then all the elements that we can find when we are looking at it vertically means from top to down, or in a column form, can be called group. If we have understood that, then we realize that there are 8 groups on this periodic table. You have group 1 starting with hydrogen, lithium, sodium, and potassium. Then there is group 2, that is beryllium, magnesium, and calcium. Group 3, boron and aluminium. Group 4, carbon and silicon. Group 5, nitrogen and phosphorus. Group 6, oxygen and sulfur. Group 7, fluorine and chlorine. Group 8, helium, neon, argon. Now the thing about hydrogen is that there is a bit of a controversy on where hydrogen should be placed, but for the purpose of this lesson, let's put hydrogen at group 1. In the future lessons, we'll have sort of like an argument, or we'll look at schools of thought about where hydrogen should be placed. Now when we look at periods, we have 4 periods. Periods, we are looking at the elements, how the elements are arranged from the left to the right or horizontally. Now on period 1, we have hydrogen and helium. Period 2, we have lithium and beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. Period 3, we have sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, and argon. Period 4, we have potassium and we have calcium. If this lesson has really been well understood, you can leave a like on this video. Hit the subscribe button so that you receive our future videos as and when we post them. Then share your thoughts with me in the comment section. Now, this is a special request I'm going to make to everybody. If you have any topic in science or in math that you did not understand when it was being taught in school, or you do not understand, put that in the comment section. I'll visit it, look at it, then I'll make a video to help you understand. Studying with Delta is all about learning. I want you to understand that science and math can really be understood. We'll take it one day at a time, one lesson at a time, until we strike at the heart of your problem. Thank you for joining me and for seeing the video up to this point, which means you enjoyed it or you learned something from it. I'm going to leave some practice questions at the end of the video so that you try your hands on them. Practice makes man perfect. Thank you very much. Bye for now.